Welcome to helpyourmath.com. In this video, we're going to look at complex fractions. First, let's talk about what a complex fraction actually is. A complex fraction is a fraction that contains a fraction in either the numerator, the denominator, or both. So we could see a complex fraction such as 2 over 3 over 4 over 9. Or we could see one, we could have 2x over y plus 3 over 7. So the first one's a complex fraction because the numerator has a fraction and the denominator has a fraction. The second one is a complex fraction because the numerator is itself a fraction. We could have just the denominator be a fraction. So we'd have x plus 4 over x plus 1 over x. We could have something like that. We could even have a slightly more complex fraction such as 1 over x plus 2 minus 1 over x over 1 over x squared minus 4 minus 1 over x squared. We could see something like that. So these are just some examples of complex fractions. How do we deal with complex fractions? Well, let's just take one example. Let's go with the first one because that one's nice and numeric. So we have 2 over 3 over, let's try that again, over 4 over 9. Well, one thing we can do is remember that all fractions are division. So we could take any of these fraction bars and rewrite it using this symbol. And usually we want to find the breaking point between the actual numerator and actual denominator and rewrite it that way. So we could rewrite this as 2/3 divided by 4/9. And then we can use the property of fractions that says we can take any division of rational numbers and rewrite it as multiplication. 2 over 3 times 9 over 4. And once it's written as multiplication, then we can try to simplify it. So I can simplify the 3 and the 9, I can simplify the 2 and the 4, and then I can multiply straight across. So 2 over 3 over 4 over 9 ends up simplifying down to 3 over 2. Not so bad. So that's generally what we want to do. We want to take the giant division and rewrite it using this, and then rewrite the division of fractions as multiplication by multiplying by the reciprocal of the divisor. So we want to simplify this one as much as humanly possible. We have x over 6 over x over 8. The first thing I want to do is just rewrite it x over 6 divided by x over 8. Now we can say, okay, great, it's a division of fractions. We can rewrite by using the property that says it's the same as multiplying by the reciprocal of the divisor. Once it's written as multiplication, so only at this point can we look to simplify. So I can simplify here the x's, and I can simplify the 6 and the 8 because they both have a common factor of 2. And now once I've done that, I can multiply straight across, giving me 4/3. Now there is one trick to complex fractions. Well, not one trick, another trick. We have to make sure we can't actually go from step 1 to step 2 unless the numerator is one single term and the denominator is one single term. In this example, it was fine. I think most of the examples in here are fine, but the last example, we're going to see that the numerator is not just one term, it's multiple terms. And so we're going to have to deal with that as well. But this example, while it does look kind of complex, this one is the numerator is just one term and the denominator is just one term. So the first thing I'm going to do is I'm going to rewrite it using the division sign. So 2x plus 4 over 5 divided by x plus 2 over 15. Now I can rewrite it 2x plus 4 over 5 times 15 over x plus 2. Now I want to see if I can pull out any common factors. However, I do have a binomial that I think I can factor. 2x plus 4, there's a GCF of 2. So I can rewrite this as 2 times x plus 2. So now every polynomial is factored, and then I can just look at the numbers separately. But I see that I have a common factor of x plus 2 now, and the 5 and the 15. And look at that, my denominator became 1, so I no longer have a denominator, and I'm left with 2 times 3, which is 6. So that whole monstrosity in the beginning ends up just equaling 6. In this next example, we still only have one term, so this is good news. We can immediately rewrite the fraction bar using the division sign. That would be x minus 2 over x squared plus 6x plus 9 divided by x squared minus 4 over x plus 3. Now that I've rewritten it as more arithmetic looking division, I can invert and multiply. So x minus 2 over x squared plus 6x plus 9 times x plus 3 over x squared minus 4. And at this point, I might want to factor what I can factor. So x minus 2 is its own factor, and x plus 3 is its own factor. X squared plus 6x plus 9, that's going to factor into x plus 3 times x plus 3. That's a perfect square trinomial. And x squared minus 4 will factor into x minus 2 times x plus 2. Now we can look for common factors. We have one factor of x plus 3, one factor of x plus 2. This time the numerator turned to all ones. When the numerator turns to ones, we must include a 1 as the numerator. And we're going to have 1 over, what do we have left? X plus 3 times x plus 2. And you want to check with your instructor to make sure you can leave your answer with the denominator factored, or if you need to expand, multiply and write it out in standard form. Our last example, so here's the one where we have a problem. This numerator has 1, 2, 3 terms. So I cannot immediately change this to the division symbol using the division symbol. I have to get that numerator to be 1 term, not 3 terms. Same thing with the denominator. The denominator has 2 terms. So we're going to work on these separately. The numerator, we want to turn into 1 term, so we actually need to do the subtraction. I'm going to write it as 3 over 1 minus 1 over b minus 2 over b squared. So if I'm going to be able to subtract, I need a common denominator. The least common denominator between 1b and b squared is b squared. The first term needs a factor of b squared, so I'll multiply that to the numerator and denominator. The middle term needs a factor of b, and the last term's fine. It already has the denominator we need. So now I can write this as 1 term with a denominator of b squared, and we're going to just clean these up. That's 3b squared minus b minus 2. And that's it. Now it's 1 term. So we went from 3 to 1. Yay! Next, we're going to look at the denominator, and we're going to have to do the same thing. So the denominator, we have 1 minus 1 over b squared. That's like 1 over 1. So here, the least common denominator is also b squared. This factor needs everything. It needs the b squared, and the second one is just fine. So now I have my common denominator of b squared. The numerator I have b squared minus 1. So now I have 1 term in the numerator, 1 term in the denominator. Now I can rewrite these using the division sign. So if you want to bring it all back together, you can. Just due to lack of space, I'm not going to. I'm going to go ahead and say this is 3b squared minus b minus 2 divided by b squared divided by b squared minus 1 over b squared. Now I can rewrite by using multiplication. That would be 3b squared minus b minus 2 over b squared times b squared over b squared minus 1. That is a lot of b squareds. Now we want to factor anything that can be factored. 3b squared minus b minus 2. There's a target product of -6 and a target sum of -1. The winning combination, there is a winning combination of -3 and +2. So I need to go off somewhere. I'm going to go up here just to save space over there. So I'm going to rewrite 3b squared minus b minus 2 as 3b squared minus 3b plus 2b minus 2. So just using that winning combination to create 4 terms so that I can do factoring by grouping. Now I'm going to pull out the GCF. That'll be 3b, leaving me with b minus 1. The second grouping, we have a GCF of 2, leaving me with b minus 1. Now these 2 terms have a GCF of b minus 1, and it was being multiplied to 3b and 2. Okay, so this becomes b minus 1 and 3b plus 2. B squared, we don't need to worry about factoring. B squared minus 1, that's a difference of squares. That's going to factor into b minus 1 times b plus 1. Now let's look for some common factors, the b squareds. And then there's a b minus 1 in the numerator and denominator, leaving us with our final answer of 3b plus 2 over b plus 1. And there you have complex fractions.